So here we are in fourth period with, we're going to go over test hints 13 through 24. Please make sure you watch the rest of the video clips so that you get 1 through 12 and the questions that come after 24. Alrighty, number 13. The test hint says, define isotope. What is an isotope?
Isotope has a greater number of neutrons.
Okay. Isotope, greater number of neutrons. What if it has a smaller number of neutrons? Is it still an isotope?
No.
Yes. Just a different kind. So isotopes can vary with however many, with the number of neutrons that they have. They're still isotopes. So it's a general name for atoms that have varying numbers of neutrons. And of course, those neutrons affect the mass, which you're going to see when you look at test hints 1 through 12 that we went over in the other class. Alrighty, number 14. Determine the number of protons, neutrons, and electrons in a given isotope. Now this will be giving you a specific, well, the answer choices will give you several examples. So, let's see. How can I put this? Number of protons, is this correct? Phosphorus, which has an atomic number of 15 and a mass of 30, has 15 protons and 16 neutrons. Phosphorus 30. Does it have 15 protons and 16 neutrons? No. Why? Right. We added these together, we get a different mass. We get 31. Is there an isotope of phosphorus that has a mass of 31?
Yes.
Yes, there is. And how do we know that? Yeah, the mass number, the average atomic mass up there. Mass, I'm glad you said that, because mass number is this. The average atomic mass is the one up there with the decimals. And that is closer to 31, so 30.9. So we know there are other isotopes of phosphorus because the average atomic mass in the periodic table isn't a nice rounded off number. Alrighty, 15, determine the number of protons, neutrons, electrons in a given isotope. That sounds exactly like number 14. So we have an element with atomic number 26 and mass number 56. Element with atomic number 26, mass number 56. Element, who knows what? Oh, it's iron? How do we know it's iron? What number are we using to tell that it's iron? The 26. That's the number of protons. So we know we're talking about iron. I don't have to have a question mark here because we know it is indeed iron. And how many protons, neutrons, electrons?
There's 26 protons.
26 protons.
30 neutrons.
Why are there 30 neutrons?
If you add the protons and neutrons together, you get the mass.
Okay, so 30 plus 26 will give us 56. And how many electrons? 26. Okay. What if an answer choice... I got out a new marker. I forget which one was the good one. What if an answer choice said 26 protons, 30 electrons, 26 neutrons? That would be horribly wrong. Okay, but that's what one of the incorrect answer choices will look like. They might have the right numbers, but put the wrong particle with it. Okay? Or it might have used the number 56 for one of the particles. Alrighty. 16, describe an atom in greater detail than our hint number 2, but similar to hint number 6, which you guys didn't get to hear until you go on Moodle to watch it. But this question will be, oh, this is one of those, which of the following statements is not true? You with me? Other Kyle? You with me? Which of the following statements is not true? And it might be something like, atoms of the same element have different masses. Is that a true statement?
No.
Atoms of the same element have different masses?
Yeah.
Yes, because
There's isotopes.
we have isotopes. Okay, so that would not be something that we pick for this question. What if it was something like atoms have hardly any empty space in them?
That's false.
That would be false. So atoms have a lot of empty space. So when it asks which of the following is not true, that would be an example of an answer that is in fact not true. It's important in this question to read through all the answer choices. Okay? 17, define atomic mass unit. Yes, it's called AMU. And what is it based on? Atomic mass unit is based on our reference atom. What is our reference atom for all the masses on the periodic table? No.
Nitrogen.
Used to be hydrogen years ago. What is it now?
Carbon.
Carbon, what kind? Yes, you do. Carbon who? Carbon 12. Carbon 12 is our standard of mass. So, and one atomic mass, if carbon weighs 12, then one atomic mass unit is how much? 1/12 of that. Which happens to be 1, which is hydrogen, so it makes sense that you might say hydrogen at first. But and AMU is defined as 1/12 the mass of carbon 12. Okay, 1/12 of 12. Number 19. Describe how the atomic mass of an element is determined. So, how do we know what the mass of nickel would be?
You add the amount of protons and neutrons together.
Protons and neutrons. Do we need to know what thing we're comparing it to? Do we need to know what element we're comparing it to? That helps. Yeah, and what element are we comparing to? Carbon 12. Okay, so these are relative masses. You're going to see with the Bean Lab today, the Bean Lab will definitely be something to study for this test. You're going to see how we're using lentils as our reference bean to compare all the rest of them to. And then with the real atoms, we use carbon 12 to compare all the masses of the other atoms to. Alrighty. Oh, number 20. I love this question. Love it.